Hello everyone, this is Dr. N. Amudapriya, Associate Professor Tripling of Rovini College of Engineering and Technology, Palkulam. We are discussing about the course Transmission and Distribution, and this is the third lecture of the first unit, which comprises of the capacitance parameters of single and three-phase lines. While considering the capacitance, normally in inductance we used to calculate the flux linkages before calculating the inductance, and we used to find out the inductance from the flux linkage values by dividing it by the current. In capacitance, what we normally use is we used to find out the voltage value, the voltage impacted due to the charge present, and from which we can calculate the capacitance. So let us consider a single phase transmission line which consists of two conductors, which has one has a charge of plus q and the other one minus q. Both the conductors are of radius r. While considering the voltage VA, we can have the impact of plus q as well as minus q. For plus q it is obviously from r to infinity, and for minus q it is d to infinity, I mean the distance between A and B. This is how we calculate VA. And similarly, when we are calculating for VB, we have to consider minus q and then plus q. So this VA and VB. Let us consider VAB. Obviously, it is 2VA. While you are adding it, you will be getting, and the capacitance is nothing but q by V. So when you are having this, you can directly calculate the capacitance of the single phase transmission line. Here we have a CAN, which is nothing but the neutral current, neutral capacitance, which can be CAN as well as the CBN value, and this is equal to 2CAB. Next, let us see about the three-phase overhead transmission line. Let us first see about symmetrical spacing, that is equal spacing between the three conductors A, B and C. While considering VA, it is from R to infinity, q by 2 pi x into epsilon dx, and while considering the other two, it will be from d to infinity. We are going to add up, integrate, and then while substituting the value of qa plus qb plus qc to 0, we get VA, from which we can calculate CA, I mean the capacitance of conductor A. While considering the unsymmetrical spacing, here the transposed line will be having a constant distances. So we can see from for AB the distance is D3, for BC it is D1, for AC it is D2. So this will be practiced for each transposed set. And you can see three positions here. First, let us see about the first position, second position and third position. In the first position, A conductor is having a radius of r. I mean we are going to consider first A conductor alone. So it is 1 by r. And while considering the B, it is D3. And here we have, while considering C, it is D2. And next go to the second position. QA is the same, sulfur, so it is 1 by r. While considering QB, it is D1. While considering QC, the distance is D2. While considering the third position, for QB it is D2 and for QC it is D1. While adding up all those things and taking an average, we get VA value, and this VA value is being used for calculating the capacitance Q by V value. Thank you.